Welcome back. In this lecture, we're going to talk about rotators. Now, rotators are a fairly simple concept, but before we get started, we're going to talk about coordinate systems. So far, we've been looking at three-dimensional space like this. We have x, y, and z axes. Now, there are two conventions when it comes to using a three-dimensional coordinate system. There's this way, and there's this other way. Notice the coordinate system to the right has its y-axis pointed in the opposite direction. Now, the coordinate system to the left is known as the left-hand coordinate system, and the coordinate system to the right is called the right-hand coordinate system. The right-hand coordinate system is the most intuitive and easy to grasp, as it's simply the x and y axes placed flat on the ground with z coming up parallel to both of those axes. And for that reason, we've been using that coordinate system for our examples thus far. Now, different game engines use different coordinate systems. Unreal Engine actually uses the left-hand coordinate system. So that's the coordinate system we'll be working in from now on. Now, let's talk about rotators. Imagine that we have an object in the world, just a white sphere. Now, this object has its own x, y, and z axes, and they may or may not be aligned with the world x, y, and z axes. So what we see depicted here in this image is an object whose x, y, and z axes are aligned with x, y, and z of the world. But we still have to keep in mind that this object has its own local x, y, and z. Now, an object's local x-axis, also known as its x-vector, is considered to be its forward vector. So the x-axis for an object is pointing in that object's forward direction, and its y-axis is considered its right vector. And perhaps most intuitively, its z-axis is considered to be that object's up vector. Now, let's say that we take this object and we tilt it by 45 degrees up. Now, notice that its x-axis and its z-axis are now tilted. They're no longer aligned with the world x and z, but its y-axis hasn't changed. It's still aligned with the world y-axis. So essentially, we've twisted this object about the y-axis. What we've done here is we changed the object's pitch. Pitch is defined as the rotation about the y-axis for a given object. So as we twist this object about the y-axis, we're changing that object's pitch. Now let's consider a different example. Let's say we tilt the object this way. Notice that the x and y axes are now tilted away from the world x and y, but the z-axis hasn't changed. We've twisted the object by 45 degrees about the z-axis. Think of this object like an olive, and we've stuck a toothpick straight down from the top and twisted it. We've now changed this object's yaw. Yaw is defined as an object's rotation about the z-axis. Now let's consider a final example where we twist the object by 45 degrees this way. Notice that the y and the z axes for the object are 45 degrees off from the world y and z, but the x hasn't changed. We've twisted the object about the x-axis, and by doing this, we've changed the object's roll. So roll is defined as rotation about the x-axis. An object has a yaw, pitch, and roll, and when the object is in its base rotation, it hasn't been twisted in any of the axes, we say that its yaw, pitch, and roll are all 0. So this object, aligned with the world x, y, and z, has yaw, pitch, and roll of 0. Now, we can store these three values in a mathematical construct similar to the vector. Where the vector has x, y, and z components, a rotator has pitch, yaw, and roll components. So these are just three scalar values, just like a vector's x, y, and z, only these are rotational values. In Unreal Engine, a rotator stores yaw, pitch, and roll in degrees. So if an object has a yaw of 90 degrees, that means it's been rotated about the z-axis 90 degrees to the right. We're going to get plenty of practice working with rotators throughout this course.